Hi Year 8. So today's lesson is about extracting metals. That's our title for today. So if you haven't already got that written in your book, pause this now, write your title and underline it, ready to start. Okay, so our first thing we're going to have a go at today is a little starter that I've got on the slide, and it's a bit of a recap of some stuff that you actually covered a few lessons ago now. It's to do with the lesson on metals and acids. So I want to see whether you can remember this stuff. Two questions at the top there. What gas is produced when a metal reacts with an acid? How can we test for that gas? And then I've got some equations with some missing words. So I would like you to maybe jot down the answers for this. So whether you do it in the front of your book or your back of your book or just on a piece of scrap of paper, I don't mind. But I'd like you to have a go at just writing down those answers to make sure you've thought about those questions. If you need to click back in your book, you can. And if you want an extra challenge, there's an extension question at the bottom. So pause this slide now and press play when you are ready to start again. Okay, so the very first one there, what gas is produced when a metal reacts with an acid? Well, that is hydrogen. So hydrogen gas is produced when a metal reacts with an acid. Then next it asks how we can test for this gas. Well, we test for this gas using a lit splint. And if there is hydrogen there, we'll get that squeaky pop sound. The equations, if we've got calcium reacting with hydrochloric acid, now this is where we said we had a salt, something called a salt plus hydrogen, and the name of the salt had two parts. It's a bit like we have a first name and a surname. The first part of the salt name comes from the metal, so it's going to be calcium, and the second part comes from the acid. In this case, because it's hydrochloric acid, it will be calcium chloride. Similarly, when we've got zinc and nitric acid, we get zinc nitrate, but you've been given that this time, we get zinc nitrate, and the other product is hydrogen again, because whenever we react a metal with an acid, we always get hydrogen gas produced. And finally, we've got magnesium plus sulfuric acid, and we'll get a salt plus hydrogen again, and this time the name of our salt is magnesium sulfate, and there it is. Now, if you had a go at the extension question, you could make magnesium chloride by reacting magnesium metal with hydrochloric acid. That would make magnesium chloride plus your hydrogen again. And calcium nitrate you could make by reacting calcium with nitric acid. I wonder if you said those things. Okay, let's have a little look what we're going to do today. So today we are going to describe what an ore is. You might know already, but you might not. And then we're going to explain why some metals occur naturally as their elements, whilst others are found as something called minerals. And we need to know what a mineral is. You'll have heard of those, but not necessarily in this context. Now we're going to use the reactivity series, which we have met before, to explain which metals can be extracted from their ores by reacting them with carbon. Okay, I've got 4 key words on the board on the slide here, and I've got 4 definitions. You don't need to write this down just yet because we'll be writing down some sentences using these words later on. But first of all, I want to see if you can match up the words to their correct meanings. So pause this, take a moment to read the meanings. Some of the words you probably haven't met before, but some you have. See if you can work out which meanings match to which words. Have a go at that now. Okay, so our top definition there is a list of elements from the most reactive to the least reactive. Well, we definitely have met that before, and that is our reactivity series. So well done if you've got that. Removal of oxygen from a compound we call reduction. So when we add oxygen to a compound, we had a lesson where we looked at reacting metals with oxygen. We call that oxidation. The opposite of oxidation is reduction. A rock containing enough metal to make it economic to extract is called an ore. And unreactive metals found as elements in nature are known as native. Now, most metals don't exist naturally as just the metal. So most of them are in rocks as compounds. And up at the top here, we've got a picture here of some iron ore. And it's this kind of reddish brown colour, and this is just in rock. And how do we get from that rock to the iron that we can use to build things like this bridge here? I think that's Iron Bridge, from a place called Iron Bridge. So how do we get from the rock to the metal that's really, really useful for us and we use to make all sorts of different things? Maybe you've already got some idea how this happens, but let's have a look at this in more detail. Okay, so most metals aren't found just, as I said, as the metals in nature. They're found as compounds, which we call minerals. So that's what a mineral is. It's a metal compound which is found in rocks. And if there's enough of that metal compound in the rock, then we can class it as an ore. So when I say enough, it's can we get enough metal from that piece of rock in order to make it worthwhile economically? That means, is it going to be worth enough money once we've got the metal out? So if it costs lots of money to get the metal out of the rock and then the metal's not worth very much afterwards, then we wouldn't class it as an ore. But if there's plenty of metal in there, we can get the metal out and then we can sell it for more money afterwards. It's economically viable, we would say, then we would class that as an ore. But we need to get those metals out from that rock, and we call that extracting it. So we say these metals need to be extracted from their ores. So different words there. Minerals, that's the compound containing the metal, and that compound is found in rock. If there's enough of that metal compound, then we call the rock an ore, O-R-E, and we have to extract the metal from the ores so that we can use them. And these pictures at the bottom, in case you're wondering what they are, this is a big open cast mine. This, I think, is an iron ore mine. And they dig the rock out of the ground to send it to be extracted. And this is another mine where they're mining for a different metal. And this is an underground mine. So they've dug tunnels, and obviously they've got railway tracks there to try and get the heavy rock out as well. Okay, so most metals are found as ores, and there are 3 different examples of metal ores and a little idea of what they look like. So the one on this side here is called bauxite. So they have special names, but bauxite, the mineral that it contains that we're interested in is aluminium oxide. So we need to extract aluminium from that rock so that we can use aluminium. The one in the middle here, this one here, is called hematite. And that's iron oxide, that's an iron ore. And over on the right here, we've got something called malachites. And this one's actually copper carbonate, so we can get copper from that rock. And interesting, that's a very different colour, because you might know what colour copper metal is, but copper compounds are often this kind of greeny colour. Well, that's the colour of copper carbonate. And if you've ever been up to Alderley Edge and walked along the edge there, if you look at some of the rocks at Alderley Edge, you might see some of that green colour in some of the rocks at Alderley Edge. because they used to mine some copper at Alderley Edge in the past. So you might see some copper compounds still in some of the rocks there. You might have known that all along, or some of you might have thought that that green colour was actually moss or mould growing on the rocks, but it's part of the rocks, and it's this copper carbonate causing that green colour. So many of these ores contain metal oxides. Certainly these two on the left-hand side there are metal oxides. And metal oxides are just metals that have reacted with oxygen. So an example there being our iron oxide. Gosh, lots of information so far. We've not written much down yet. Bit more information, then we will write something down. Okay, so here are 3 examples of metals that aren't found in ores. So having said most metals are found combined with other compounds, often oxygen, and are ores, gold, silver and platinum are found naturally as just those metals, not combined with anything else. So not all metals are found in ores because they don't react with other elements. So the reason why these are found as pure metals in the rock is because they are unreactive. So they tend not to react with other elements, including oxygen. So gold is very unreactive. Remember, it was really near the bottom of our reactivity series. Likewise, silver and platinum. And that's what makes them valuable. They're really unreactive and they are rare, so it makes them really valuable. Oh gosh, I wonder how much you have remembered. Okay, so I've got 3 questions on the board, or on the slide. You need to have a go at answering these, and I would like you to write these in your book. So where it's got the sentences and it's got ... question mark, so I'd like you to actually write the whole sentence down. So first one, rocks that contain minerals from which metals can be extracted are called, you're going to add the missing word. So every sentence, copy it out, add the missing word, press play when you're ready to start again. Okay, so our top one here, rocks that contain minerals from which metals can be extracted are called ores. So that's O-R-E-S. Hopefully your writing is tidier than mine. Metals are usually found in their oxidized form, which means they have combined with, I'm going to have to write this underneath because I haven't left myself enough space there, they're combined with oxygen. Oxygen. And finally, metals such as something don't react with other elements and aren't found as ores. Now you need to have chosen one of the metals on the previous slide, which is gold, silver or platinum. Any of those 3 will work in that final sentence there. Did you tick them with a green pen, or have you corrected them if you didn't get them right? If not, do that now. I think we've already done these top 2 things. We've described what an ore is. Oh, definitely, we've just written that in our books. And we've explained why some metals occur naturally as their elements, while some are found as minerals. We haven't really written that down to answer that question or say why that is exactly. Can you tell me now out loud why that is? Why do we find some just as the elements? And why are some found combined with other elements? We find them as compounds and therefore they're minerals. Did you say it was to do with how reactive they are? So if they're really unreactive, like our gold, our silver and our platinum, we find them just as their elements. The more reactive metals, we tend to find them combined with other elements like oxygen, and we call them minerals. Right, let's see if we can do our third thing on this slide now. Let's carry on. Now, we've met the reactivity series before, and what I want to know is how you could obtain iron from iron oxide. So there's our reactivity series. Remember, we've got our most reactive metals at the top, right the way down to our least reactive one at the bottom. And metals which are less reactive than carbon can be extracted from their oxides by heating them with carbon. So do you remember when we did our lesson about displacement reactions? So this is an example of a displacement reaction. So if we had iron oxide, because carbon is more reactive than iron, it can displace the iron from the iron oxide, so we'll end up with iron plus carbon dioxide. Okay, so heating with carbon will reduce some metal oxides to their metal elements. And this is a really important example of a metal which is extracted in this way. So iron is extracted this way. Iron oxide plus carbon, as I just mentioned, will give you iron plus carbon dioxide. And it is an example of a displacement reaction. It's also a reduction reaction because we're removing oxygen from the iron. I'd like you to pause this and write everything down which is on this slide. It says there, write down this equation. The equation is important, but I actually would like you to write everything down that's on that slide. So this reaction that we've mentioned of heating iron oxide with carbon happens in something industrially called a blast furnace. This happens on a huge scale. These are massive things. And in a minute, I've going to show you a link to a video. It's up to you whether you watch that video in amongst this lesson, if you like. If you pause this video, go and watch that video and come back to this video, or whether you want to watch it at the end of the lesson. So I'll give you that link separately. When you watch that video, it will talk about some different words. It will talk about something called Coke. And I want to mention that because they're not talking about Coca-Cola. They're not talking about a fizzy cola drink. Coke is something which is basically carbon, so it contains a lot of carbon. So they add carbon in the form of something which they call coke to the blast furnace, along with the iron ore as well. And the carbon reacts with the iron ore. It steals the oxygen away from the iron oxide, if you like. You get that displacement reaction going on, and the carbon reduces the iron oxide to iron. Just like in that equation that we had before. But this all happens in something called a blast furnace. What comes out of the bottom after it's all reacted is molten iron, so it's very, very hot, so you get your iron out, and something called slag, and that's just all the other things that are left over at the end. So there we go. In a blast furnace, carbon reduces iron oxide to iron. So there's our metal ore, the iron oxide, and we get our metal, which is our iron. Right, there's the link to the video that I mentioned. I will pop that in Classroom for you. It does say on there to use the video to explain in your own words what happens inside the blast furnace. I actually think that's quite complicated to do. So I'm going to leave that up to you, whether you want to do that. It's kind of, I think it's a nice to have, but if you want to just watch that video and just to find out a little bit more about how this process happens, that's fine. If you want to jot down a few sentences about it, that's great. You could, if you want to, also draw a diagram in your book of the blast furnace, but again, if you find that a bit complicated, I'm happy for you to leave that. So I'm going to leave that as an optional task. That one's up to you. This, however, is not optional. I would like everybody to have a go at this task. So let me explain what I want you to do. So I mentioned that carbon is reducing iron oxide to iron. We've got our equation written again there. So other metals can also be extracted in this same way by heating the metal oxide with carbon. So long as carbon is above the metal in a reactivity series, and all these metals in this list are above carbon, so they will all work. And I want you to write out word equations for the reduction reaction of the following oxides by carbon. So in each case, you're going to have to start with the metal oxide that's there. You're going to have to write plus carbon. Whoops, really difficult writing with a mouse on the screen. You're going to have to write plus carbon. And then you'll have your arrow in the middle, remember? So these are a bit near the middle of this slide. Put them over the left of your page, don't put them in the middle. And you're going to have 2 products each time. And I'm going to let you try and work out what those products are. So have a go. Use the equation at the top here to help you to work out what would happen each time. They all follow the same pattern. Pause this now. Have a go. When you're ready to mark your answers, press play. Okay, so here are the answers to all those, or here are all those equations written out properly. So zinc oxide plus carbon will give you zinc plus carbon dioxide. Tin oxide plus carbon will give you tin plus carbon dioxide. Lead oxide plus carbon will give you lead plus carbon dioxide. Copper oxide plus carbon will give you copper plus carbon dioxide. Tick them with your green pen if you got them correct. Okay, just to make sure we have got all this information in our notes somewhere in our book. This looks like a lot of words. It's just really a short paragraph, all the writing I promise you is quite big there. I would like you to copy this paragraph down, and where there are lines you need to fit in one of the words that's at the bottom. If you get to a missing word and you're not quite sure which word it is, the length of the line will give you an idea how big the space is that you need to leave for that word. So draw the line and leave it blank if you're unsure, and then have a go at filling in the words at the end if that's easier. If you're really stuck, leave that space blank, and when you press play, we'll go through the answers and you can check what you've got. If you can underline the missing words as you go along, even if you are filling them in, it will make it easier for you to check them when you press play again. So pause this now, copy and complete this paragraph for me. Okay, so let's have a go at this. Metals come from the Earth's crust. Some metals are very unreactive and are found as elements in their native state. Metals such as zinc, iron and lead are found combined with oxygen in compounds. These metals can be extracted using chemical reactions. The metal oxides are reduced as oxygen is removed from the compound. Well done if you've got all of those right, because some of these terms we haven't met before this lesson, so that's really good. Well, just one last question, I think, on these slides. And this question is, could you use carbon to get calcium from calcium oxide? So I've shown you where carbon is. I've shown you where calcium is. Remember, for this sort of reaction to work, for it to be a displacement reaction, my carbon would need to be more reactive than my metal that's in the compound, metal is actually more reactive than carbon, so this isn't going to work. So it won't work because calcium is more reactive than carbon. Metals that are more reactive than carbon can't be extracted by heating with carbon. Instead, they are extracted by a different method called electrolysis, and we'll learn more about that next lesson. Okay, so enough for today. Lots of new information today. But I think we've done everything we set out to do. I think we've described what an ore is. I think we've explained why some metals occur naturally as their elements, whilst others are found as minerals. And we've used the reactivity series to explain which metals can be extracted from their ores by heating with carbon. So remember, it's the metals which are beneath or below carbon on the reactivity series that can be extracted in the way that we've described today. I have two things left for you to do. If you've not already watched the video about the extraction of carbon, take a little while to do that, to find out more about that. As I said, it's optional if you want to draw the diagram of the blast furnace and write a few sentences about that. That's an optional task. However, a task that I definitely want everybody to do is to have a go at the Seneca task that I have set for you. It's been set for you in Seneca, so if you've already used Seneca before, you just log into Seneca, it will be set as an assignment for you. Some of you have not yet signed up to my Seneca class, so if that involves you, use the link at the bottom of the page in Classroom to click on that link, and it will take you to Seneca Learning, and it will ask you to set up an account. That's absolutely fine to do. It's free. You can use your school email address. It will ask you to set your own password. I suggest you write that down in your planner. Write Seneca Learning down and write your password down, because it's not a website that I have any control over. It's an external website. And so if you forget your password, I can't find it out for you. You can click remind me, or I've forgotten my password, but that takes a little while to sort out. So try to write that password down. Good luck with the Seneca task. Enjoy the little video, and thank you very much for listening today.